5.7 goes over systems of linear inequalities. So like you saw in 5.6, we're working with these linear inequalities. However, now you have more than one, so it makes it a system. With these, you're used to seeing these linear equations, and where those two lines cross is your solution. However, with inequalities, you want to take into consideration that shading, and where those two shadings overlap will be your answers. Okay? So we're going to start this lesson off by telling whether each ordered pair is a solution to the system of linear inequalities. So we're doing the same thing we would if we were doing a system of equations. We're going to plug in that x value for x. In both of those inequalities, plug in that y value for y in both of those inequalities and see if you get true statements. If you have true statements for both of the inequalities, it's a solution. If not, it's not a solution. So if we look at example 1a, we have y is less than 2x, as well as y is greater than or equal to x plus 1. We're given the ordered pair 3, 5. So we're going to plug the 3 in for x, the 5 in for y, and then simplify. So we're going to have the top equation is going to become 5 is less than 2 times 3. The bottom equation is going to become 5 is greater than or equal to 3 plus 1. For the top equation, that 2 times 3 is 6, so it gives us 5 is less than 6. For the bottom equation, the 3 plus 1 is 4, so that gives us 5 is greater than or equal to 4. These both are true statements, so in fact, that 3, 5 is a solution. For example B, we have y is less than 2x and y is greater than or equal to x plus 1. Now we're given the ordered pair -2, 0. So the -2 will plug in for x, the 0 we plug in for y. If I work with my top equation, I'm going to have 0 is less than 2 times -2. And my bottom equation is going to become 0 is greater than or equal to -2 plus 1. For the top equation, that 2 times -2 is -4. So 0 is less than -4. For the bottom equation, that -2 plus 1 is -1, so 0 is greater than or equal to -1. The first inequality is incorrect, however, the second is true. Because the first inequality is incorrect, then it deems that -2, 0 is not a solution. For example C, we have y is less than 5 as well as y is greater than x minus 4. We're given the ordered pair 1, 5. So if we plug in the -1 for x and the 5 for y, we're just going to have 5 is less than 5 as well as 5 is greater than -1 minus 4. That -1 minus 4 simplifies to be the 5 is greater than -5. So for these two, that 5 is less than 5 is false. However, the 5 is greater than -5 is true. So because that first one is false, that -1, 5 is not a solution. For D, we have y is greater than or equal to 3x plus 1, and y is greater than x minus 1. We're using the ordered pair 1, 4. So if we plug the 1 in for x, the 4 in for y, this is going to give us 4 is greater than or equal to 3 times 1 plus 1, as well as 4 is greater than 1 minus 1. The 3 times 1 is 3. 3 plus 1 gives us 4 is greater than or equal to 4. The 1 minus 1 on the other is going to give us 4 is greater than 0. If you look at both of these, you have true statements for each, so that 1, 4 is a solution. When we go to graph these, we're going to graph these just like we did in the section before this. We're going to graph each of these inequalities and shade where they belong or where the shading belongs. However, The only part of the shading that we are going to keep is the part that overlaps. So if we look at example A, we have y is less than or equal to 3, which gives us a solid line that goes through 3 on the y-axis. The shading for this one would be below that line. So I'm just going to draw lines underneath it so that way I see where the shading for this exact line belongs. Then I'm going to look at my next line. I have y is greater than x plus 2. So I'm going to have my y-intercept of 2. So my first point goes on that 0, 2. Then my slope is 1. So I'm going to go up 1 to the right 1. I'm going to keep this trend going throughout the entire coordinate plane and make sure that I have it on both sides of that y-intercept. From there, I am going to draw that dotted line or that dashed line through these points to make sure that line goes the entire width of that coordinate plane. And I will be shading above the y values above this line because y is greater than the x plus 2. So the only shading that I want to have here is the shading that overlaps. So the two areas where this shading overlaps is where I'm going to either darken my shading or just highlight over to indicate that that only part is where the shading is that I want. For example B, we have y is greater than 2x minus 3. We are going to have a y-intercept of that negative 3, or a b value of that negative 3, I'm sorry. And our slope is 2, so we're going to go up 2 to the right 1. Up 2 to the right 1. And again, I'm going to do this throughout my entire coordinate plane, so that way I have a precise line when I go to draw my line through these points. Now, through these points is going to go a dotted or dashed line to indicate that the line or the symbol that we have, that inequality sign, is not also equal to. It tells us y is greater than that 2x minus 3, so the y values on that y-axis that I want shaded are the ones greater than negative 3. So it's going to be anything above this line. From there, I'm going to look at my second line. I have y is greater than or equal to 1/2 x plus 1. So I have a y-intercept of 1 and a slope of 1/2. So I'm going to go up 1 to the right 2. Up 1 to the right 2. Keep this going throughout the entire coordinate plane in both directions. To get my left points, I'm going to go down 1 and to the left 2 instead. This one gets a solid line through these points because it is also equal to. And then we're going to shade above as well because y is greater than or equal to. So the shading that overlaps is just in this area here. So I'm only going to keep the shading or overlap and darken the shading in this area that I have highlighted. For example C, we have negative 2x plus y is less than 4 and 2x plus y is greater than 4. I'm going to work with these two inequalities separately first, so that way I put them into slope-intercept form. If I work with the top one, that negative 2x plus y is less than 4, I'm just adding that 2x to each side to get y by itself. So I have y is less than 2x plus 4. Because this is in slope-intercept form, I can graph this line. I'm going to have a y-intercept of 0, 4, so I plot my first point at that 4 on the y-axis. And I'm going to go up 2 to the right 1. Up 2 to the right 1. I'm also going to go down 2 and to the left 1 as well. Now, this line is going to be a dashed line through these points to indicate that that line has an inequality symbol that is not equal to. It tells me y is less than 2x plus 4 because that less than is there. I want the y values shaded below that 4 on the y-axis. Now I'm also going to take that second line of that 2x plus y is greater than 4 and solve that one for y as well. So I subtract that 2x from each side, and we get y is greater than negative 2x plus 4. That's giving me a y-intercept of 4 and a slope of negative 2. So I'm going to go down 2 and to the right 1 from that 0, 4 on the y-axis. I'm also going to go up 2 and to the right, or sorry, up 2 and to the left 1 to get the other part of that line. This line as well is a dashed line through these points. And my shading for these is going to be above, those y values above this line, because y is greater than. So I'm only going to highlight now the area that is overlapping with shading. So that's going to be in this area here. For your next set of examples, you are graphing the system of linear inequalities. For 3a, we have 2x plus y is less than negative 1, and 2x plus y is greater than 3. So I'm going to take that first inequality, that 2x plus y is less than negative 1, and solve it for y. So I'm just going to move the 2x over by subtracting it from each side, and we get y is less than negative 2x minus 1. So for this one, I'm going to plot the first point at negative 1, then use my slope of negative 2 to go down 2 to the right 1. I'm going to keep this going throughout the entire coordinate plane and go into the opposite direction 2 by going up 2 and to the right 1. And I'm going to draw a dashed line through these points. And my shading is going to go below this line since y is less than, and I'm going to have this area here shaded. For that other inequality, we have 2x plus y is greater than 3. So I'm going to subtract that 2x from each side, and we get that y is greater than negative 2x plus 3. If y is greater than that negative 2x plus 3, I'm going to plot that first point at 3, and then I'm going to go down 2 to the right 1. Down 2 to the right 1. Oops, not 3. 2. I'm also going to go up 2 to the left 1. And then again, I'm going to draw a dashed line through these points. And I'm going to shade the y values that are above this line, so all of this area. Now you'll see here that these two shadings don't overlap. So when that happens, then you have something like no solution. For example B, we have y is greater than or equal to x plus 4, and x plus y is less than or equal to 0. That y is greater than or equal to x plus 4 is already in slope-intercept form. So all I have to do is plot the y-axis, or the y-intercept, which is 0, 4, and then my slope is 1. So I'm going to go up 1 to the right 1. And again, I'm going to keep this going throughout my entire coordinate plane, in either direction, or in both directions, I'm sorry. So that way I get that precise line. And then I'm going to draw my line through these points. My line is going to be a solid line, since my inequality sign also indicates that it's equal to. And then I'm going to look back and say y is greater than or equal to x plus 4. So my y values that are going to be shaded are going to be the y values on that y-axis that are greater than 4. So that would be above this line. Now that other line that I was given, that x plus y is less than or equal to 0 is not in slope-intercept form. So I'm going to have to move that x over by subtracting it from each side. We get y is less than or equal to negative x. We don't have a b value here, so automatically it's 0. So the first point that I'm going to plot is that 0, 0. From there, my slope is negative 1. So I'm going to go down 1 to the right 1 and keep that going throughout my entire coordinate plane. I'm also going to go up 1 and to the left 1. And then draw that solid line through these points since I have a inequality sign that is also equal to. It tells me that y is less than or equal to negative x. So if y is less than, those y values that are going to be shaded are going to be less than that y-intercept, which is 0. So it's going to go below that line. I'm going to keep this shading going. And then check where these two shadings overlap. The area where these two shadings overlap is this area only. So I'm going to darken or highlight over this area to indicate that's where my answers are. Your next part of your lesson is when you are given a graph and you are writing the system of the linear inequalities. If you look at example A, you have two lines on there. One's a horizontal line, one's a diagonal line. You need to write the equations for both of these first. So what I like to do is I like to draw or write these equations of these lines in slope-intercept form as if it was an equation, not necessarily an inequality. Then I go back and I ask myself what type of line I have and where my shading is to give me that inequality symbol. So for example A, I'm going to work with that solid horizontal line first. I know that since it's a horizontal line and it goes through that y-axis at negative 2, that's just y is equal to negative 2. Now, if I look at that diagonal line, I have a y-intercept of 0, 0. So my b value is 0. My slope is going up 1 to the right 1, up 1 to the right 1. So that's a slope of 1. This line is going to be y is equal to, my slope is m, which is 1. So that's 1 times x, which is just x. And my b value is 0. So that's plus 0, or just y is equal to x. Now, look at your shading. If you look at that y is equal to negative 2, where is the shading? It's above that negative 2. So that includes the y values above it. So y is going to be greater than negative 2. Do I have a line underneath that? Well, is my line solid? Yes. So I have to have that equal to as well. For that y is equal to x, what type of line is it and where is the shading? My shading for this line includes the y values that are below that y-axis or that y-intercept. So that's going to be that y is less than x. Now, what type of line do I have? Is it solid or is it dashed? It's dashed, so I do not put a line underneath that inequality sign. So my system of linear inequalities is just going to be y is less than x, as well as y is greater than or equal to negative 2. Work with these one by one first, put it in slope-intercept form, then change your equation or your equal sign to an inequality symbol, depending on the way your line is drawn and your shading is going. For B, we have two lines here. One of them is a vertical line that goes through that x-axis at 3. So that would just be x is equal to 3. The other is a diagonal line that goes through the y-axis at negative 1. So we have a b value of negative 1. And we have a slope that's going up and to the right. So if I use this point here, I'm going up 2 to the right 3, so my slope is 2/3. This is giving me the equation y is equal to 2/3 x minus 1. If I then look at those lines to see what my inequality symbols are going to be, for that x is equal to 3, I have a solid line, and my shading is to the left of that line, so those x values that are being covered are less than that 3. So that's going to turn into x is less than or equal to 3. For that diagonal line, my shading is above that line, so y is greater than. It's also a dashed line, so it's going to stay greater than 2/3 x minus 1. So to put this all together, I have x is less than or equal to 3, and y is greater than 2/3 x minus 1. For example, 5a, we have these two lines once again. For that diagonal line, I have a y-intercept at 2, at 0, 2, so my b is 2. I have a slope that's going down 1 and to the right 1, so my slope, my m, is negative 1. So this is going to give us y is equal to negative x plus 2. For that vertical line, it goes through 3, so that's just x is equal to 3. Now figure out what your inequality signs are going to be for each of these. For that diagonal line, my shading is below the line, so that's going to be y is less than negative x plus 2. It's also a dashed line, which is why it's staying just that less than and not becoming y is less than or equal to. For that vertical line, my shading is to the left of that 3, so those are the y values that are less than, the x values that are less than 3, so that's just x is less than 3. And again, it stays that less than, not less than or equal to, because it's a dotted line. So to write my system, I'm just going to have x is less than 3, as well as y is less than negative x plus 2. For example B, these two lines, we're going to work with the line that has the y-intercept at 1. So our b value as 1. Our slope, we're going down 1 to the right 2. So it's negative 1 over 2. That's giving us y is equal to negative 1/2 x plus 1. Now with this, your shading is going above this line. So that would turn into y is greater than negative 1/2 x plus 1. It is a solid line, so you want to put that equal to underneath that inequality symbol as well. So your final inequality for that line is going to be y is greater than or equal to negative 1/2 x plus 1. For the other line, you have a y-intercept of 0, negative 3, so your b value is negative 3. You have a slope that's going up 2 to the right 1, so your m value is a positive 2. This gives you y is equal to 2x minus 3. The shading for this would be below, those y values below that negative 3. So y is going to be less than 2x minus 3. We have that solid line, so we put a line underneath that inequality as well to give us that y is less than or equal to 2x minus 3. To write this as a system of inequalities, you're going to have y is less than or equal to 2x minus 3, as well as y is greater than or equal to negative 1/2 x plus 1. Now, you may be curious about why I put a specific inequality first within your system, and to be totally honest with you, it does not matter. So as long as you have both of them that are correct, your system's going to be correct.